probably already know, chemistry is super important. It's what's responsible for our delicious muffins rising, sunscreen protecting us from those harmful UV rays, and the rusting of our beloved Statue of Liberty. Acids and bases can be seen everywhere, from the lemons we eat to the soap we wash our hands with. Acids are proton donors that yield hydronium ions in a water solution. Bases, on the other hand, are proton acceptors, which yield hydroxide ions in water solutions. The cool thing about acids and bases is that they can come together and neutralize each other. Just like when you go to the therapist and neutralize your anger.
These neutralization reactions yield molar ratios that can be used to find the molar mass of an unknown acid and to standardize a base.
Now, you might be wondering, what does standardizing a base mean? Well, it's when you use titration to determine a concentration of a base against known mass of an acid. So, we take the known mass of a KHP, a solid acid, and add it to water to form a solution of a known molarity. We add an indicator to the solution that will turn light pink when it reaches the equivalence point. When moles of acid equal moles of base, the reaction is complete. We then take NaOH of an unknown molarity and put it into a burette and let it drip into the KHP solution until it is light pink. If it turns dark pink, then it's been over-titrated.
Here's a representation of what is going on. Pretend Leah's shirt is the solution of KHP, and the snowballs are drops of NaOH. As NaOH is dripped into KHP, the solution becomes titrated and turns a light pink as it reaches the equivalent point. If the solution passes its equivalence point, the solution becomes a dark pink. We can then use the molar ratios from the reaction. KHP plus OH yields Kp and H2O to find unknown molarity. We first use the mass of KHP that we had measured out and convert it to moles. Then we use the molar ratio from the equation to convert moles of OH, then moles of NaOH. Then we subtract the final volume of NaOH from the initial volume of NaOH to find the NaOH needed to titrate the solution and convert it from milliliters to liters. We then put moles of NaOH over liters of NaOH to get the molarity of NaOH.
The objective of the next portion of the lab is to find the molar mass of an unknown solid acid. We repeat the same procedure, except this time we know the molar mass of the NaOH from part 1, and the mass of the unknown solid acid.
Here's a depiction of what is happening in the lab. We first attach a burette filled with standardized NaOH to a ring stand and put a beaker of KHP solution underneath the burette. We let the burette drip into the KHP solution until it is titrated or becomes over-titrated.
We titrate until the solution reaches equivalence. We can then use the equation HA and OH minus yields A minus and water, where A is the unknown acid, and use the volume of NaOH needed to titrate the acid to find the molar mass of the acid through stoichiometric conversions.
First, we subtract the final volume of NaOH from the initial volume of NaOH to find the NaOH needed to titrate the solution, and then convert it from milliliters to liters. We then convert liters of NaOH to moles of NaOH, then moles of OH and moles of HA. Finally, we put the mass of HA over moles of HA and get the molar mass of HA, which determines its identity.
If you were paying attention, you may have learned acid and bases are complicated, throwing snowballs at Leah is fun, how to use a fun burette thingy, but seriously, how to find the molar mass of an unknown solid acid, how to standardize a base, and how to use a neutralization reaction to find the unknown solid acid. This episode of Crash Course was written by Leah and Molly Smith and performed by me, Mickey Geffert.